Hey everyone. Because we can't be together to go over mini quiz 5, I've prepared a video where, since we often just shout out the questions we have, I'm just going to go through every question. It turns out it's really hard to print a quiz off of Brightspace, so we're just going to use the preview and go question by question, which means it should look exactly how it looks for you. The downside is I'm kind of tied to my computer, which means I'm going to have to jump back and forth between this browser and then an Excel sheet for anything that involves calculations. All right. So question 1 tells us that water flow is a natural monopoly. And then it asks us about the most important barrier to entry that stops other firms from competing with water flow. And in that case, the key thing we're going to watch out for here is that it's a natural monopoly. So what we mean by a natural monopoly is that it has economies of scale or increasing returns to scale. The other factors can all create a monopoly, but none of them are what results in a natural monopoly. For question 2, we've got one of these nice little figures of some electricity producer that we haven't specified, and we want to find the profit maximizing quantity of output. Remember, with a monopolist, as with a perfectly competitive firm, we're going to set marginal cost equal to marginal revenue. And we can see that right here, where the blue line and the red line intersect, or at the intersection of P and R, where my cursor is. At that point, we can drop down and we can find that the profit maximizing quantity of output is R. Now we have the same figure, but I'm asked about the profit maximizing price. Well, we already did the first part where we found this intersection between marginal cost and marginal revenue. And the key is we're not going to charge price P because at quantity R, consumers are willing to pay a lot more than P. And as a monopolist who wants to maximize my profits, I'm going to charge the consumers as much as they're willing to pay. And at a quantity of R, if I take my cursor vertically up, it's going to hit the demand curve at price N. And so N is going to be our profit maximizing price. Now it's math time. So now we have a natural monopoly that's making electricity. We've got a real electricity theme today. And we have a demand curve which is mapped out with this relationship between price and quantity. And then we also have the cost curve mapped out. So what this shows us right here, this price per megawatt and the quantity are going to show our demand curve. And this total cost we can use in order to figure out what the marginal cost is. So I've copied this over here so we can zoom in and see it. It's the same. You should see the numbers are the same. And so what we want to do here is we want to reflect on the idea here. I just need to wrap these because otherwise it's going to drive me crazy. Let's see. There we go. Okay. So what we're going to do is we're going to remember that a monopolist profit maximizes at MR equals MC. All right. So what that means is we need to figure out what MR and what MC is. Remembering that the marginal revenue is the change in total revenue divided by the change in quantity, and the marginal cost is the change in total cost divided by the change in quantity. So hopefully you used a piece of paper to go through with this, but what I'm going to do is I'm going to calculate the marginal revenues, and what I can see is that if you do this, you've done it wrong. Do not do this, right? First, we have to figure out what the total revenue is. And remember, the total revenue is just that price times the quantity. And I'm just going to do this like this. All right, so this is the price times the quantity, and that's the total revenue. Then, if I want the marginal revenue, like I said, it's the change divided by the change in quantity. So essentially, it's 1,100 minus 600 divided by 2 minus 1. Or rather, we're kind of ignoring this because it's always a step of 1, but if it weren't the case, we'd have to be careful of that. And then we just drag that down. All right, and these should look like the differences here, right? Total revenue goes up by 500, up by 400, up by 300, all the way down. Now, total cost we already have. So then what we can do is we can calculate the marginal cost as the same thing. I'm just going to take 1,300 minus 1,200, the change in total cost, but I'm going to divide by the change in quantity. And then, because I have the glory of Excel, I can follow this down. So essentially what we can do is compare marginal revenue to marginal cost. So this first one, marginal revenue is greater, so we're definitely going to produce that unit. Marginal revenue is still greater, so we're going to produce that unit. Marginal revenue is still greater, so we're going to produce that unit. For our fifth megawatt, 200 is less than 250, so we are not going to produce that unit. So we're going to stop at 4 megawatts. So if we go back to our question, we need to know what the price is. So to sell 4 megawatts, I'm going to go all the way up to the demand curve, which is 450. So I should charge 450. At 450, consumers will demand 4 megawatts, and at 4 megawatts, my marginal revenue equals my marginal cost. So it's the same process that we did with the figure, except that we're just using it in our numbers. So just get ready when you're presented with a table like this that you'd have to add new columns so you can get to the marginal revenue and marginal cost that you need. Now we've got a nice situation here where we know that we have a firm. It's perfectly competitive. It's got some positive economic profits, and we know a few things about her business. We know her output, we know her price, and we know her average total cost. So with this, we should be able to figure out all the pieces we need. So when I've got a problem like this that doesn't include all the information that I'm expecting, right? It's kind of presented in a weird way. What I do is I kind of write down the stuff that I know. So I'm just going to, again, because of my weird screen sharing situation, I'm going to just jump back and forth here. So what do I know? I know the price is 15. I know her output is 5,000. And I know her ATC is 11. And what I want to know is I want to know what profits are. So there's two ways we know profits. We know profits are total revenue minus total cost. And the other way we can think about them is price minus ATC times quantity, right? And this is because if you take total revenue and divide it by quantity, you get price. If you take total cost and you divide by quantity, you get ATC. So this one here is going to be the formula we need because we have all of those pieces. Conversely, if we weren't sure and we didn't remember this formula, we could remember, TR is P times Q, and we could remember, TC is ATC times Q. Either way, that should get you to this or manually calculating out those two components. So if we start with this, what this tells us is we need to take the difference between price and ATC, which means that she has a profit of an average profit of $4 per bulb. She sells them for 15, her ATC is 11, so she gets 4 per bulb. And then she sells 5,000 bulbs. So 5,000 times 4 is going to be 20,000. Or if we're doing this here, we can say we're going to take 15 minus 11, and we're going to multiply it by 5,000, and that will get us $20,000. Now we've got a dead weight loss question. I hope you all nailed this. So here we have a monopolist. What's different about this versus our earlier ones is that we've made their marginal cost completely constant, such that the marginal cost and the average total cost are the same. This is just a simplification, but it makes it a little easier to see all the shapes. So our monopolist, when they profit maximize, they set marginal revenue equal to marginal cost. The price they charge is where that quantity hits the demand curve. And then we can figure out their profit, their consumer surplus, and their dead weight loss. B, we should remember, is their profit. A is their consumer surplus because it's the difference between the demand curve and the price that they pay. And then this is the dead weight loss, area C. So that's the area where there are consumers who would be willing to pay, but not as much as the monopoly price. And because of the cost structure, the monopolist would still make some money off them. And so these are sort of losses associated losses and surplus associated with a monopoly. This is the inefficiency that a monopoly is creating by restricting the quantity and charging a higher price. All right, so now we have a situation where we have Happy Bakes and suddenly their fixed costs go down and we have no pictures. So we have to figure out what to happen here. So the question is, what does Happy Bakes do to maximize their profits in response to the change in fixed costs? So This one is really tricky for two reasons. So first of all, we have to know that in a perfectly competitive market, Happy Bakes is a price taker. That is, Happy Bakes can't change the price. That's not something Happy Bakes can do. So that means we definitely have to maintain the price, which means that we're down to options A or B. Now, it might be really tempting to say that Happy Bakes is going to increase their production. After all, fixed costs went down so they can afford to make more. But that would be the incorrect answer. Don't do that. This is the correct answer. The reason why it's the incorrect answer is because what determines profit maximization is where marginal revenue equals marginal cost. And fixed cost doesn't really affect the marginal cost because the marginal cost is how much cost changes as you produce one more. And so the fixed cost doesn't make any difference at all. It will affect their profits. It's going to offer them positive profits, which is going to be great for them. But it's not going to affect their decision in either way. If you're not sure, you can write it out and write out an example under a variable cost and a fixed cost structure, and then you can see what happens when you change the fixed cost. But you'll see the marginal cost doesn't change, so there's nothing to change in this decision. Our next question looks at what happens when a monopolist goes from a single price monopoly to perfect price discrimination. And as we talked about in class, what that means is that the monopolist is able to charge each consumer their willingness to pay. And therefore, consumer surplus, which is that difference between the price and the demand curve, the price now reflects their willingness to pay, so there's no consumer surplus. So it will certainly decrease. And in fact, if it's perfect price discrimination, it will actually be zero. All right, for this one, we're back to a table, and now we have to think about the minimum short-run shutdown price for a barista in a perfectly competitive market. So the thing for us to remember is that if you check back in the textbook or your lecture notes, the minimum short-run shutdown price is the minimum AVC, average variable cost. That's a bit of a mouthful, but a simpler way of thinking about it is that in the short run, her shutdown price is equal to the AVC. Because if the price is below the AVC, then she can't even cover her variable costs on average. She can't cover the costs of the milk and the coffee and the electricity. If her price is just above the AVC, then she can cover all of those expenses and she can pay a little bit toward her fixed costs, such that it's better than shutting down when she can pay nothing towards her fixed costs. So that's kind of the intuition here, is we want to find the average variable cost because that's going to determine her shutdown price. And the minimum one is the one that has the smallest average variable cost. That's the whole idea. So what this problem asks us to do is to find that average variable cost and then pick the smallest. So we're given quantity and we're given total cost. So let's start by finding the variable cost. Now, what we know is that if we produce 0, we have no variable costs, which means that our fixed cost is 12 because the total cost is 12. But the fixed cost is fixed. It's always 12, right? Which means that the variable cost is going to be total cost minus the fixed cost because total cost is just broken down into those two pieces. So therefore, this is 14, this is 21, this is 30, and so on. Now we just use the glory of spreadsheets to make our lives a little better. There we go. So that's the variable cost. Now we don't want to minimize the variable cost. We want to find the minimum average variable cost. And the average variable cost is just the variable cost divided by the quantity. So it doesn't really make sense when we have nothing. But for example, if we have, let me just make this a little bigger. If I have a variable cost of 14 and it's spread out over one item, that's an average variable cost of 14. But here I have 21 spread out over 2 items, so that's 10.5, 30 spread out over 3. And what you can see is that like all ATC curves, or most of them, not all, it tends to fall and then rise. So this is the one that is the smallest, which means her minimum short-run shutdown price is 10. If the price is at least 10, she will stay in business in the short run, even if she might be losing money. But in the long run, she would shut down. If the price is any lower than 10, then she would shut down even in the short run. For this one, we have a firm in a perfectly competitive market, which has this demand curve, and we want to know what the total revenue is of this company. Well, we remember that total revenue is price times quantity, and we can see that the price is $3 because it's a perfectly competitive firm and we're just hold the price. It's going to follow the market demand curve. So we just have to know what the quantity is. With all firms, they profit maximize when marginal revenue is marginal cost. So we find the intersection between the blue and the red line. The thing we have to remember is that when we see that market demand curve, that is the marginal revenue curve. What that means is every item you sell, you get $3. So that is a marginal revenue curve, which means that the firm sells 300 at $3 each, which means their total revenue is $900. Now we have the same figure, and we're asked about the long run profits. We don't even need to look at this because in a perfectly competitive market, long run economic profits are zero. Essentially, what will happen is this firm right now is making positive profits because the price is above the ATC at that profit maximizing quantity. This will attract new entrants into the market. The supply curve will shift to the right, and this will push the price down, and people will keep entering the market until we get to the point at which we're equal to the ATC. Now we have a market for chocolate chip cookies. It's perfectly competitive. It's initially in long run equilibrium. And each cookie is 25 cents each. Now the cost has increased such that the marginal costs go up by 10 cents and the average total cost goes up by 10 cents. Our question is what happens when we're back in the long run equilibrium again? So the insight here is that in the long run, price is going to equal the ATC. Because if the price is greater than the ATC, new firms will enter, and if the price is less than the ATC, firms will leave. So at equilibrium, we're at zero economic profits, which means that if the average total cost goes up by 10 cents, the price has to go up by 10 cents, which means that the answer is 35. It was 25, it goes up by 10 cents. Now we've got a giant table. This looks fun, right? So we're back to profit maximization. We check, it's perfectly competitive market. We need to set marginal revenue equal to marginal cost. And in this case, all the information we need is right here. So the market price is 28. And so what we want to do is find where marginal revenue is marginal cost. This market price is the marginal revenue for a perfectly competitive firm. And so we just need to find the point at which it's equal. So it's still greater, 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 less. So we never have a point where it's exactly equal. So we go as close as we can without going over, which means we're going to produce 7 units. Now, the thing we need to check is we should make sure that we are at least covering our average variable costs. We could also try to figure out if we're making money or not. If you go down that road, you'll see that we're losing money. But we exceed the average variable cost of 16, which means we are going to produce 7. If this average variable cost was greater than 28, then we would actually shut down in the short run. In perfect competition, the demand curve for an individual firm is completely flat. Remember, we just saw it. It was up here. There it is. Look at that. That is a perfectly elastic curve. So it is completely flat. A demand curve for a monopolist is downward sloping, right? And we've seen that picture. All right, so this last question is a little bit tricky because it's kind of a secondary concept, but it's still an important one. So we're thinking about the relationship between price and quantity, basically along a demand curve. Essentially, the underlying concept here is kind of why it is that monopolists may charge a higher price, but they don't charge like $1 million to everyone because they lose all their customers. So essentially, I'm going to paste it over here just because I think it makes things a little bit easier to see. But we have Ms. Johnson, and she is selling 8 jars of honey at $40 per jar. And if she reduces the price to $35, she can sell 9. So essentially, there's 2 worlds. There's world 1, which is the $40. And in this case, she sells 8 jars for $40. And when the price is $35, she sells 9 jars times 35. So you can see that when she reduces the price, the revenue that she has actually falls. Now, the reason why this happens is because of this price effect and the quantity effect. So the price effect is the idea that for these 8 people she used to sell to, she used to charge 40, but now she can only charge 35. So the price effect is essentially 8 for her old customers times the fact that she receives 35 when she used to get 40. So basically the price effect is $40. That's what she loses. And then the quantity effect is the fact that she brings in a new customer. She goes from 8 jars to 9 jars, and she now sells that for $35. So she sells one more person $35. And so the change in total revenue is going to be the sum. Right? So we can see revenue drops by 5, and we can see over here that revenue drops by 5. Well, not the way I did it there. There, now the revenue drops by 5. So in both cases, here we can see total revenue falls, and here we see it's driven by a price effect and a quantity effect. And so the effect is equal to $35, and then the price effect is equal to negative $40. And so that gives us our answer. All right, thanks if you're still with us, thanks for sticking through all 15 questions.